was reading about industrial waste, and it's worse than I thought.
Yeah, and it's not just the amount, it's the toxic stuff like chemicals and heavy metals.
And a lot of it just ends up in our water and soil. That's a serious problem.
The traditional treatment method can't handle all of it. We need something more effective.
That's where enzyme immobilization comes in. Maybe it's the solution we need. Let's dive into how it works.
Every year, industries worldwide produce vast amount of waste, much of which ends up polluting our environment.
Every day, the Philippines generates thousands of tons of waste, much of which ends up in landfills, rivers, or even in the ocean.
In the Philippines alone, urban areas generate significant quantities of solid waste daily, posing serious environmental challenges.
In 2022, the Philippines generated over 21 million metric tons of waste, a figure that continues to rise each year. Industrial waste is not just a problem of volume, but also toxicity.
These waste often contains hazardous chemicals, heavy metals, and organic pollutants that contaminate soil and water sources.
In fact, the textile industry alone is responsible for 20% of global water pollution.
Many factories release untreated or poorly treated wastewater into nearby rivers, affecting both the environment and local communities.
So this is where biochemistry steps in. Enzymes as nature catalyst has the ability to break down complex pollutants into simpler and less harmful substances.
Enzymes regulate the rate at which chemical reactions proceed without itself being altered in the process. Each type of enzyme may be capable of degrading specific pollutants and catalyzing chemical reactions. Therefore, certain enzymes can treat only certain types of organic pollutants in a highly specific manner. Knowing the composition of the pollutants in the discharge effluent will allow the deployment of the right enzyme for the purpose.
Unlike harsh chemicals, enzymes are highly specific, efficient, and biodegradable. For example, lactase enzymes can break down toxic dyes in textile wastewater, while proteases and lipases are used in food processing waste treatment. However, free enzymes are often unstable, costly, and not reusable, which limit their industrial application.
To overcome these challenges, scientists have developed a technique known as enzyme immobilization.
There are several ways in which enzyme immobilization can be done. These include adsorption, ionic binding, covalent binding, and entrapment method.
This process involves attaching enzymes to solid supports like beads, membranes, or gels, making them more stable and reusable. By binding enzymes to carriers like resins, silica, or natural fibers, we create systems that can efficiently break down complex pollutants.
Immobilized enzymes can withstand harsh industrial conditions and may be used repeatedly, significantly reducing costs.
While promising, enzyme mobilization faces challenges like high initial cost, potential enzyme inactivation, and mass transfer limitations.
However, advancement in nanotechnology and bioengineering are helping overcome this hurdles. Researchers are now exploring hybrid systems that combine physical and biological processes for maximum efficiency.
Enzyme immobilization stands as a beacon of hope for sustainable industrial waste treatment.
By integrating this technology, industries can significantly reduce their environmental footprint, conserve water, and reduce greenhouse gas emissions.
Let's advocate for and adopt innovative solutions to ensure a cleaner, healthier planet for future generations.